This is a lesson on 12-3 in geometry. So if you get out your note sheet, we're going to fill in the table you have. Let me give you some background information though. Before we fill out that chart at the bottom of your note sheet underneath the opening, let's go ahead and talk about exactly what this information on this chart is going to tell us. So just listen for this part and understand what we're starting to look for. We're going to look at the number of possibilities if you take subgroups, subsets of a bigger group and put them either in order or not in order. How many different ways can you pick those groupings? So as an example, if let's say that you're going to go to go out for an adventure with some friends, and your folks say you can bring 2 of your 3 friends. Okay, sorry, you can't choose all 3. You got to pick 2 of them. So if you are picking them, you're just going to go for a walk. Then order doesn't matter. You guys are going to just be in a group, and so it doesn't matter which order you're in. So that means when you pick your friends, you could pick, for instance, Mike and Joan. You could pick Mike and Zach, or you could pick Joan and Zach. You know, Zach and Joan, Joan and Zach, same thing if you're just going for a walk. So order doesn't matter. There's 3 different possibilities you could pick for picking 2 friends out of the 3 that you could pick from. Now, what if you had to put them in order? Let's say that you're going to invite your friends, but you got to put them in the car. So who's going to sit in which seat? You've got 2 captain's chairs behind the driver and the regular seat. And you're going to put 2 of them in that seat. So order matters. So it makes a difference between whether Mike sits here and Joan sits here, or the other way would be for Joan to sit here and Mike to sit in the other seat. So it makes a difference. Mike and Zach, and then switch directions, have Zach sit here and Mike sit here, and then Joan and Zach, or Zach and Joan. So notice that you're going to have more possibilities if you put them in order. So that's what we're going to find out when we do these. This is going to involve some mathematics. So we want to introduce some new mathematical notation. So first of all, I'd like to introduce you to what's called factorials. And you may have done this in previous math classes or may not. A factorial, all it means is it looks like this. For instance, if I had n factorial, means that you're going to take whatever number that is, say it's 7 factorial, and you're going to multiply it by every number below it, every integer below it, all the way down to 1. Okay, so multiply n by every positive integer less than n. Okay, so what it would look like is we'd have, if we did the formula, be n factorial would equal n times n minus 1 times n minus 2, and you just keep times and you keep going till you get down to 2 times 1. So all the integers lower than it. Let's do a couple examples. I mean, with n's, it kind of looks funny. It's not as hard of an idea. If I wanted to do 4 factorial, that's just 4 times 3 times 2 times 1. That gives me 24. And if we wanted to do 5 factorial, well, it's the same thing as that, just add a 5 on the front. 5 times 4 times 3 times 2 times 1. So it'd be the same as 5 times 24. That would give you 120. So they start going up pretty fast once you get higher numbers. Okay, so factorial, that number times every positive integer below it. All right, permutation now builds on that. Basically, this is the key idea here. I'm going to put a key idea. It's order matters here for permutation. So like up here when we did the example of sitting in seats, sitting on the left seat or the right seat makes a difference. So it's different if you have them in the left or the right. So what this is going to be is we're going to select our term items from n total items. Okay, so up here, for instance, we've selected 2 items out of the 3 total. So that would be R would have been 2 items from 3 total items. And here, we're going to put them in order and put them in order. Okay, so that's a key idea. The notation for this is we put a little n, a capital P, and a little r. That's going to be n permutation r for how we calculate this. The formula for this, NPR equals, you're going to use this factorial up here. So what you're going to do is you're going to take the total number, like up here it was 3, so you're going to do n factorial, and you're going to put it over n minus r factorial. So you're going to subtract off the number that, you're going to take the total number and subtract off the number that you've picked to put into order. So up here, as an example, let's say we did this one up here. We had, this was in order, so what we are going to do is we're going to have 3 total. Permutation, we're going to select 2 and put them in order. So let's see what that calculates out to be. So you're going to put the 3 factorial in the top, and in the bottom you're going to do 3 minus 2 factorial. Well, that's 3 factorial over 1 factorial. Well, 1 factorial is just 1 because it's 1 times any number below it. Well, there's no other positive integers below it. So that's going to be 3 times 2 times 1 over 1. That gives me 6. Notice there were 6 options there for that. All right, let's do one more example. Let's do 15. This is a little bit bigger one. We're going to do 15 P, and then we're going to select off 5. Okay, so that's a big group of 15 items. We're going to pick 5 and put them in order. How many different ways could we do that? Well, it's going to be a pretty big number. So let's go ahead and we're going to do in the top 15 factorial. And in the bottom, you're going to do 15 minus 5. So let's go ahead and do that in our heads. 15 minus 5 is 10. 10 factorial. So this, now I'm going to show you a shortcut for doing these. What I'm going to do now is I'm going to do 15 times 14 times 13. I'm going to do this below just because it's going to be hard to read here if I do it too small here. So 15 times 14 times 13 times 12 times 11 times, now what comes next is 10 times every number below it. Well, that's 10 factorial. What I'm going to do is realize that if I list it like that, I'm going to take this 10 factorial, which represents 10 times 9 times 8 times 7 times 6, all those numbers below it, and let's just cancel these guys off. It reduces out because there's going to be a 10, a 9, an 8, a 7, a 6, and the top and the bottom that can reduce out. Now all I have to do is multiply 15 times 14 times 13 times 12, and I get for a total 360,360 for the total. That's a total number of ways I can take 5 items and put them in order out of the 15 total. All right, so let's do the last one now. Make sure you get that written down. If you have to, pause the video to write that down, because in a minute I'm going to have to erase that. I'll do this one in blue down here so we can see it. All right, so here we're going to do, for this one, order does not matter. Okay, that's for combinations. Okay, so here we're going to select our items from a total of n and put them in any order. Okay, so we're going to select R items from N total items and put them in any order. Order does not matter here. Okay, the notation we use, and there's also a word that we use with this one. So the notation we use is N with a C for combination R, and we oftentimes will use it, say it this way, N choose R. Okay, it's a short way of saying that phrase, okay? So when we do this, let's do our notation or our formula. So NCR, N choose R. The formula looks just like this one, N factorial. It's going to be over N minus R factorial. We're going to include just like we had there, but we're going to have more to cancel out. Instead, we're going to have an R factorial out here. So not only will we have the N minus R, but we'll also have that R by itself factorial. So there'll be an N factorial on the top, an R factorial on the bottom, and an N minus R factorial down here. All right, let's do a couple examples. Your examples will go on the side here. Let me see if I can do one down here without erasing. I'll just do it right below here. And so I'm going to do this one. So this is good, would have been 3 choose 2. Okay, for this one, we notice we only got 3 as an answer. So that should be 3 factorial over 2 factorial times 3 minus 2 is 1 factorial. Okay, 3 factorial is equal to 6. 3 times 2 times 1. 2 factorial is 2 times 1, that's 2. 1 factorial is 1, so it's over 2. And so I get 3 as an answer. Okay, and there was only 3 possibilities, so we counted them out. Let's do one more example down here. Let's do 15. Notice that this is going to be a lot less. 15 choose 5. It could be a lot less than this one here because we're going to have more in the denominator to reduce out. And it makes sense because this one, you're putting them in order, so there's more ways to put things in order than just to pick a group of 5 and just put them together as a group. All right, so this one, we're going to do 15 factorial on the top. In the bottom, we're going to have the 5 factorial. And then 15 minus 5 is 10 factorial. Okay, now notice we had that up here. And so what we did that here, and we were able to cancel. So we had 15 times 14 times 13 times 12 times 11 times 10 factorial. And the largest one down in the bottom is what I like to cancel out. So this could be 5 times 4 times 3 times 2 times 1. And in the bottom, I'll have a 10 factorial. The 10 factorials cancel. And now I do this part on my calculator. You could do more reducing. Notice 5 could reduce with the 15. You could do a lot of work there if you wanted to. But I find it just easy once you get to this point. Just multiply 15 times 14 times 13 times 12 times 11. And then get that equal for that. Then divide it by, put it in parentheses, 5 times 4 times 3 times 2 times 1. And what you end up getting, let me go ahead and do that on my calculator here. I'm going to get, let's do 15 times 14 times 13 times 12 times 11. Okay, that gets me that 360,360. You can divide that by 5 times 4 times 3 times 2 times 1, and that gives me 120. So if I take the 360 and divide that by 120, I get 3003. So I'll just fit that right in here, 3,003, our final answer. So notice 3,003 is a whole lot less than the 360,360. So in order to do these, for some probabilities here, we're going to learn using probabilities for different situations of when order matters or order doesn't matter. Okay, when order does matter, you go ahead and use a permutation and use this formula. And when order doesn't matter, use a combination and use this formula. And you have to learn how to use the factorials in the process. And that will help us get large numbers that we can end up figuring out probabilities from. So in these problems, we'll give you situations. In just a minute, I'll give you several examples of situations. And I want you to tell me how many possibilities that there are. The first thing you need to ask yourself, does order matter? Then do it with a permutation. If order doesn't matter, use a combination. Let's go over examples of permutations and combinations. So remember, the most important thing you need to do is figure out if order matters in the situation. So I've listed our two formulas here so that we have them for these examples. Example one that I've listed here, I want you to, every time I want you to read through, as I read it, I want you to then pause and you decide, does order matter or not, and see if you can then put it into the formula. And then check when I try the problem. So the first problem is 7 friends get in line for a roller coaster. Decide if order matters and then decide what the formula should be. Okay, let's go ahead now. In this case, when you're getting in line for a ride, usually order matters. You can't just all go in at one time. You got to get in line to see who goes in first and who doesn't. So in this case, all 7 friends are going to go in. So on this one, it's going to be, because order matters, it's going to be a permutation. So it's going to be 7p7, because you're going to have all 7 of them going on it. So what that looks like is you're going to do 7 factorial over 7 minus 7 factorial, which is equal to 0 factorial. Now here's a fact that I need to make sure that you list, maybe put on the other side with your notes, but put a big box around it. This is important because it comes up frequently enough. Whenever you get 0 factorial, we're going to define that to be equal to 1, okay? So put a box around that. If you get a 0 factorial, just make it into a 1. So this one's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 1. And when we multiply all those numbers together on a calculator, you end up getting 5,040. So that's an amazing number. If you have 7 friends going, there's 5,040 different ways to put them in line in order to get on the roller coaster. That's an amazing number, but that's what order does to these. It increases the numbers quite a bit. Second example, out of 7 friends, Julie selects 3 to go to the movie with her. Pause the video, decide whether order matters, see if you can come up with a formula. Okay, let's try it. Because she's just selecting friends to go to a movie, we're going to say that order doesn't matter because they're all going to the movie. Now later, how they sit for it, that maybe in the chairs, that might make a difference as part of it. But for this one, it's just selecting 3, how many different ways she could select 3 to go with her. So on this one, we're going to use 7, choose 3 for the combination. Okay, and the combination of 7 with 3, that would give us 7 factorial over, we're going to put 3 factorial, and then 7 minus 3 is 4 factorial. I like to reduce out the largest one, so I'm going to put 7 times 6 times 5 times, and I'm going to list this as 4 factorial. Just going to put it in parentheses just to emphasize that that's hanging out together. And this is 3 times 2 times 1 as my 3 factorial. And then I got my 4 factorial here that I'm not going to expand out because I can cancel it. Or 4 times 3 times 2 times 1. All of those factors will reduce out. So I'll cancel those two. And so here, notice what I can do also. Notice I see a 3 times a 2 times 1, that's 6. That'll cancel with that 6. If you want to, you can cancel these with that up there, reduce that out, or you could just do it on your calculator. 7 times 6 times 5, get what that equals, divided by, and put in parentheses, 3 times 2 times 1. So that ends up doing, when we multiply that out and divide, you get 35 for that. So check that out. All right, so now let's do, notice the theme of 7 here in the first 3 problems. Out of 7 chess participants, first, second, and third place awards are given. So I want you to pause the video and decide, does order matter, and which formula would you use? Now that you've tried that, let's go ahead. Well, first, second, and third, yep, it does matter. Order does matter because first is different than second and definitely different than third. So we're going to use a permutation for this. So 7p3, so that's going to give me 7 factorial. And in the bottom, I'll do 7 minus 3, which is 4 factorial. It's going to be 7 times 6 times 5 times 4 factorial, which will reduce with the 4 times 3 times 2 times 1, the 4 factorial down here. And so 7 times 6 times 5, that gives me 210 for that answer. All right, so quite a bit of difference if order matters versus order doesn't matter in the number of possibilities for it. And the last one, 9 players on the baseball team are arranged on the baseball field. Pause the video, decide if order matters and which formula you would use. Okay, well, they're being put into positions, so order does matter. If you're putting the pitcher positions different than center field, so order does matter. We're going to put 9 here, P9, okay, because you're going to put all 9 of those players in the baseball team. Now, if I had said there was 13 players in the baseball team, and we're going to choose, we're going to pick 9 of those to put out on the field, that would have been 13 choose 9, but here just all 9 are being put out there. So I'm going to have 9 factorial over 9 minus 9 is 0 factorial. There's that 0 factorial again. So this could be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 0 factorial, as we defined up here, is equal to 1. And so when we multiply that all out, we're going to get 362,880. Can you imagine? That's the number, the total. If we have just 9 players in a baseball team, the number of different ways we could put that team out there on the field, the coach has to decide between 362,880 different ways to put them out there. It's his or her choice of how to arrange them on the field. So these are examples of permutations and combinations. This lesson, 12-3, is designed to help you to know how many ways there are to either put groups into order or not into an order. And then later on, we'll be able to use those as part of our probabilities.